Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will solve simultaneous equations using elimination. So the reason it's called elimination is you eliminate one variable. You eliminate whichever variable has the same number in front of it in both equations. So how do you eliminate the variable? If they have the same sign, you subtract, a different sign you add. Of course, sometimes you will have equations in which neither variable can be eliminated straight away, and in those cases you need to multiply one or both equations. So let's look at an example. So let's say we have these two equations here. So the elimination method says I want to get rid of one of the variables, x or y. Which one do I get rid of? Well, because this is a positive 1y and a negative 1y, they essentially have the same number in front of, I'm going to get rid of y. How do I get rid of y? Well, because they have different signs, what I'm going to do is add together these two equations. So 3x plus 2x is 5x, because I'm adding both equations. Negative y plus y is 0. That cancels out. They go away. That's in fact why I did this. I added the equations so I'd get rid of the y's. So then I still need to add the right-hand sides of the equation. 5 plus 10 is 15. We've reduced these two equations to one equation with one variable. If 5x equals 15, x must equal 3. So what does that mean for the value of y? We can substitute x equals 3 into either of these equations to find the value of y. So let's substitute it into here. So I get 2 times 3, 2x is 6, plus y is 10. Of course, that means y equals 4. The solution here is 3, 4. X equals 3, y equals 4 is a solution to this equation, and at the same time it's a solution to this equation. All right, let's now look at this equation here. So this is going to be more tricky. So these are tricky equations to solve. Now, using the graphical method would not be good. We'd have to use xy-intercept method to graph this, and you can see that the y-intercept here is going to be 1, but the x-intercept's 2/3. It's not going to be a whole number. It's going to be hard to make our graph accurate. There's also a problem with using substitution. Neither x nor y is the subject of either of the equations. In fact, to try and get x or y as the subject to the equation will be a bit messy. We're going to have a lot of fractions. That's why we need the elimination method. We basically need it because there are times when the graphical method is not practical, nor is the substitution method. So we're going to use the elimination method here. So which variable am I going to eliminate? That's tough, because neither x nor y has the same number in front of it in both equations. What I therefore need to do, I'm going to multiply both equations so that either x or y, doesn't matter which one, either of them has the same coefficient in both equations. So I can multiply this top equation by 5, for example, and the bottom by 3. Why would I do that? Well, if I multiply the top equation by 5, it becomes 15x. If I multiply the bottom equation by 3, it becomes 15x. Doing this will allow me to have the same coefficient of x in both equations. Then I can eliminate. Now just be careful. When you're multiplying an equation like this by 5, you need to multiply every term by 5. Terms are separated by plus or minus signs and also the equal sign. So I times 3x by 5, but I also need to times the 2y by 5, and I need to multiply the 2 by 5. Similarly, when I'm multiplying each term here by 3, I get 15x plus 21y. Now, negative 37 times 3 is negative 111. So now I've got a situation where one of the variables has the same coefficient in front of it in both equations. So I know that I'm going to eliminate the x's. So how do I do that? Well, they have the same sign. They're both positive 15. When you have the same sign, you subtract one equation from the other. The way I'm going to get rid of the x's is to subtract 15x from 15x, because that's just 0, goes away. So 15x minus 15x is 0. 10y minus 21y is negative 11y. Now 10 subtract negative 111 is positive 121. Dividing each side by negative 11, I get y equals negative 11. And you can substitute this into any of the equations, it doesn't matter. Whichever one you do, you'll get the same value of x. So if I substitute negative 11 here, I get 3x minus 22 is 2. And you know how to solve that equation. You add 22 to both sides, divide by 3, you get x equals 8. The solution here is 8, negative 11. We always write x first. So x equals 8, y equals negative 11 is a solution to this equation, and at the same time, it's a solution to this equation. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.